Hey, welcome back everybody. And for the last one that we're learning in this whole entire unit is we're going to be learning how to test the difference between two variable hypothesis tests for proportions. So let's get right into it. So back to semi-normal, other than the one where we're doing the dependent samples where we're comparing everything back to zero. Now we're comparing back to groups again. So you're going to look at these type of null and alternative setups. Except instead of using mu's, you'll be using p's because, again, we are back to talking about proportions. So, again, we're looking at two independent groups, a proportion of one or a percentage of one, and comparing it to a percentage of the other. So that will be different. The next thing, obviously, the equation will be different. We were back to using z's again because, again, these will be much larger samples than what we've been using. And a couple things you need to know about that. Number one, P with a hat over it again means sample percentage or sample proportion. We've talked about this before. That still means the same thing with obviously the subnode of 1 and 2, so you can pay attention to group 1 and 2. X will represent the number of successes. So if you think about what a percentage is, it's pretty much just a fraction, right? You have some number out of a bigger number. Well, the number on the bottom, that's your sample size. That's your n, and there will be two of them. There'll be a group 1 sample size and a group 2 sample size. The x represents the number on the top of those, okay? So the number of successes in each sample. And then last but not least, p with a bar over it, we refer to that as p-bar, is the weighted estimate for our population or claim percentages. So the way that this works is mathematically is you're going to start with getting the weighted estimate first, and then you get the weighted opposite, which again is just, we've talked about this before with percentages, P's and Q's, P's being the 1%, Q being the opposite to add up to 100. So you can use this quick little formula to get Q bar. And then the rest of it is plugging into this. So usually I start with this part, get that, and then last but not least, we plug in and get the test statistic, and then that, sets you up for your tail test, and then you are back to what you're used to doing. So let us look at an example. So example number 1, in a study of 200 randomly selected adult female and 250 randomly selected adult males, internet users, of course, 30% of the females and 38% of the males said they plan to shop online in the next month at least once. Now here's the deal. This textbook I got this from came out in 2010. Oh, how times have changed. I think pretty much it's got to be more like 100% nowadays. But think about 10 years ago, this was still kind of relatively new, shopping online. But anyway, crazy. At a level of significance of 0.10, test the claim that there is a difference between the proportion of female and the proportion of male internet users who plan to shop online. So difference meaning that they're not going to be equal to each other. So we'll say that group 1 is going to be females or adult females, and group 2 is going to be our adult male internet shoppers. So it's going to look something like this when I set up the null and the alternative. That claim will be the alternative because, again, it being different, the not equal to sign will put the claim in the alternative this time. The opposite of that would be the null, so P1 equals P2. Because it's a not equal to sign, we will be using a two-tail test, and you guys already know this, but level significance of 0.10, you would have to go, on your t-table, do a two-tail at 0.10, look all the way at the bottom, and make sure you write down that z-score. That part is, again, normal to what we've been doing. All right, let's get to the math part. So in order to throw all of that stuff back into the equation, we need to make sure we have all of the variables all mapped out. So let's take a look at what we do have. What we do know is the sample size for each of the groups, 200 and 250 respectively. We also know the percentages for each of the two groups, so 30% and 38%. So pretty much we're looking at something like this at the moment. What we're missing, though, is the x for each group. Again, if you were to take a fraction, something in this case over 200, so some number divided by 200 would give me 30%. I need that top number. I need that number of success. I need the number of females that plan on shopping in the next month. Same thing, I need the actual count of the number of male shoppers that plan on shopping the next month. So I need that X value. If you can guess, how can I get that number if I know the overall percentage and the sample size? If you guessed multiplying the percentage times that to get the actual number, you'd be absolutely correct. So let me show you the math behind this. If you are not given the X, one simple way of doing this is multiplying the sample percentage times the number of people in your study in that group, and then that will give me the actual raw count number. So 60 of those 200 females, aka 30% of them, plan on shopping the next month. Same again with the male shoppers. You take the percentage, multiply it by the sample size, and you're at 95 actual male shoppers. So now that I have all three of those statistics for each female and male groups, we can now go ahead and get started with the math stuff. So let's start with the overall weighted percentage. That's going to be taking your two X values, 60 plus 95, dividing them by the two sample sizes. When you do that, calculate it, you should be getting 0.34 in this problem. The opposite of 0.34 would be 60 something, right? So I'm going to subtract 0.34 from 1. That's the quickest way to figure out that Q bar is going to be 0.66. So now that I have my P bar, my Q bar, and all the parameters and variables, I can now finally plug everything into my test statistic formula. So I got Z equals my two percentages. Again, my first group sample percentage, the 30%, the second group for males, 0.38, our two P bar and Q bars multiplied by, and then we have 1 over the sample size of 1, and then 1 over the sample size of the second group. Now, this obviously is going to be where most people have the confusion, so if you could pause the video and go ahead and try to throw that into a calculator and make sure that you're getting the same or really similar answer to me. If you do want some, I guess, hints, the way I do this is I start by getting that square root piece first, multiplying this times this, and then putting both of these obviously in one parenthesis, the larger parenthesis, but if you're going to type those into a calculator, putting a parenthesis around just that one, and then a parenthesis around that one, getting the answer of that whole denominator, and then going back doing 0.3 minus 0.38 divided by that denominator answer, and that will probably be the safest way to make sure you do order of operations correctly. So what I got was, in this problem, negative 1.77, or roughly around there. And negative 1.77 is going to be the left of this marker, so we're in the shaded region. Shaded regions, again, means HO is false, HA is true. And because our claim is the alternative, our claim for this problem is indeed true. So that is how we do one of these problems. Let me give you another example, but this time with a little bit different information given to you. This would be the other variety of these problems. So example 2, a medical research team conducted a study to test the effect of a cholesterol-reducing medication. At the end of the study, the researchers found something interesting. 4,700 randomly selected subjects who took the medication, 301 of them died of heart disease. Well, that's a bummer, but hold on. 4,300 randomly selected subjects who took the placebo, 357 died from heart disease. Now, placebo again means nothing happened. They were really given actual any medication. While the people that did receive the medication seemed to have a less fatality rate when it came to heart disease. So the researcher wants to know if, in fact, taking this medication seems to work better at lowering heart disease than, for instance, people who don't take this medication. So maybe an unintended consequence of this medication is somehow reduces the risk of death from at least heart disease. So can we conclude that the death rate due to heart disease is lower for those taking the medication than it is for taking the placebo? So percentage of the people dying from heart disease in the first group lower than the percentage of people dying in the second group. P1 less than P2. That's going to put us in the alternative. And then the opposite of that would be greater than or equal to. So let's do left tail test. Again, this coming straight from the t-table of 0.01, probably want to be pretty certain again with that. There's so 2.3. With that level of significance, again, that's the probability that you are going to be wrong in this prediction. So you really don't want to, you want to run that number down as low as you can if you're going to start suggesting people take this medication. So obviously it's very good idea to make sure that level of significance is as close to 0 as possible. All right, next, let's get to what we know. So if you take a look at what we have 301 people that did die taking the medication from heart disease out of the 4,700. Same is true with the group that took the placebo. 357 died of heart disease out of the 4,300 people who took the placebo. What we are missing for both of these groups is the sample percentage. Now, take a second and guess, how might I go ahead and get the percentage for each group? And if you guess dividing the 301 by the 4,700 and the 357 by 4,300, you are absolutely correct. So when they give you the X and the N, you can do a quick fraction and you can get the sample percentages of each group that way. So it's either going to be presented like it was in example 1 or like this way in example 2. That's the only two ways that these problems can be presented to you. Let's start by getting the overall percentage or the weighted percentage. So add up the two X values, add up the two sample sizes, divide them, you get 0.73. Subtract that from 1 to get the opposite of that, which is going to be Q bar, and that's going to be 0.927. Certainly, last but not least, we go ahead and we are going to calculate the test statistic. Everything looks to be in the right spot, and you can pause the video and see if you can go ahead and calculate this correct. All right, so here we go. I got negative 3.46. So negative 3.46 is clearly to the left of this. Again, that's going to reject the HO. So when you're in the shaded zone, HO is false, HA is true. And one last time, again, the claim is true. So in this particular medical study, it just seemed that, I don't know if that was the point of the study, but it definitely seemed that this happened to be a conclusion that could be made out of that. This happens often in medical studies, and usually what this would mean is they would probably want to follow this up with another study to see if they can confirm these numbers, but it does seem rather good that this does seem to reduce at least the rate of people dying from heart disease. Not by a lot, obviously, but it seems like by at least a little. Anyway, if you have any questions doing these, you can obviously come to office hours. It's every day, Monday through Thursday, 1 to 2 p.m. If there are no further questions, you have a wonderful day. The assignment will look like problems like this. And then next week, we are going to put everything together. We'll do a review day, and then we will do a take-home test to close out the unit next week. You guys have a wonderful day. Bye.